everyone, this is Shivani Agarwal. I am the Assistant Professor in Department of Information Technology in Ajay Kumar Garg Engineering College, Ghaziabad. So, today I am presenting here on the topic of the software engineering, that is KCS 601. So, we start the lecture is an introduction of the software engineering. So, basically, software engineering means software plus engineering. This is what? This is the first I describe the software, then we have to describe the engineering part. Basically, it consists of programs, set of documentations, procedures used to set up and operate the computer system. So basically, software is what? Software is the program plus documentation plus operating procedures. So this is the basic of the software engineering. This is the program, documentation and the operation procedures. So first I explain the documentation manuals with respect to the programs. Programs is what? Program is the subset of the software. Program is subset of software, and the documentation procedures are further divided into the four parts, four major components. First is the analysis of or specification. Second is design, implementation and testing. So how we have to maintain these documents in the form of the analysis part, in the form of the design part, implementation part and the testing part. So first I start with the analysis part. Basically, when we start the analysis of any project or the software, then it divides into three categories. First is the formal specification, second is context-based diagrams, third is data flow diagrams. These are the basic specifications of the analysis part. Now the design. Design means we have to just draw the prototype of any software. So it is represented in the form of the flowchart and the ER diagrams. Now implementation means we have to implement the code. So we use two type of methods, that is the source code listing and the cross reference listings of in this particular documentation manuals. Basically, these four categories we used for the documentation part, not defining the complete analysis of the project. So this is the documentation manual part. And in the testing, we have to document it in the form of the test data and the test results. So we just document with the data part and the result part of any software. So this is the documentation manual. Now the operating procedures. Basically, the operating procedures divide into the two categories. First is the user manual, second is the operation manuals. So user manuals means it further divided into three categories, that is a system overview, beginner's guide, tutorials and the reference guide. So user manual means is what? That we have to describe the system. This is the overview of the system. And the second method is the beginner's guide, means suppose we have to define any software. So we just define the tutorial book with respect to that particular subject. So this is the beginner's guide. And the reference guide means we just define the system with the respective book that we have to use to describe that particular subject. So this is the reference guide. Now the operation manuals. Operation manuals for the two parts, that is the installation guide and the system administration guide. Suppose we install the any software in the system, so we required the installation manual, how we have to install that particular software into the system. So step by step procedure we have to define in the installation manual. And the system administration guide means we have to define how we install that particular software with the permissions of the administration guidance. So these are the two procedures that we use in the operation manuals. Now, what is engineering? So first I cover the software part, now comes with the engineering part. Engineering is what? Basically, engineering is the process of designing or build anything that we have to define the effective solution for everyone or anywhere. So engineering means the procedure that we have to design the software with the beautiful concept we have to inbuilt in the system, like the that is implemented in the science skills, professional skills, acquiring and applying the scientific and the economical social practice of the designing system with respect to the developing the procedures and the process of that particular system. So basically, we have to produce anything that it is required with the defined time and it is the defined cost. So this is the engineering approach. So basically, engineering is the process that we have to develop with the build up and the designing constraints with respect to the time and the cost. So this is the basic of the engineering. Now come with the definition of the software engineering. So basically we all already know about the software and the engineering. So first, previously without the engineering concept we have to develop the software, but how the performance have to improve when we implement the software by the engineering approach. So basically what is software engineering? So software engineering is an emerging discipline which is concerned with all the aspects of the software. Which type of aspect we have to cover? That is the deadline of the project, that is the quality of the project, that is the time constraint, that is the modules. So these all are the aspects that we have to cover when we design or when we have developed the software with the engineering approach. So software engineering is an emerging discipline which is concerned with all the aspects of the software production. Basically it develops the system that is systematic and it can be organized also. So we use the appropriate tools and techniques for develop that particular software, or we define the problem or techniques for developing that project in a very fruitful way. So this is the basic approach of the software engineering. Now the definitions that is defined by the IEEE and the Boehm's is the name of the scientist. IEEE define the definition of the software engineering is that it is the application of systematic, disciplined and quantifiable approach to develop, operation and the maintenance of the software. So basically what it means? It means that we have to develop any software with a defined rules and regulations, and we achieve the quality of the software with the defined time and cost. So this is the basic definition of the software engineering that is defined by the IEEE. Now according to Boehm's, the Boehm's defined that it is a practical approach of scientific knowledge in the design and construction computer programs that is associated with the documentations, develop, operate and maintain the plans of the software. So this is the these are the definitions that is defined by the IEEE and the Boehm. So these are the basic definitions of the software engineering. So basically the software engineering is a defined, or it is a structure or the systematic approach that we have to develop the software in a quality software in a defined time and the cost. So this is the approach of the software engineering. Now the characteristic of the software engineering. So basically first characteristic is that software does not wear out. What it means? It means that software does not goes any the wear out phase, but hardware is the hardware comes in the wear out phase. So this is this curve belongs to the hardware part and this particular curve belongs to the software curve. So what is the means of the hardware curve? So basically the curve divide into the three parts. First is the burn-in phase, second is useful life phase and third is the wear out phase. So what is burn-in phase? Burn-in phase means when we have to defining the software or becoming the initial stage of the software. So this phase is known as the burn-in phase. At this phase or this time in burn-in phase, we have to define the basic characteristics of the software. So that can be defined the risk, maximum risk over there, maximum faults over there. So this is the burn-in phase, because at this time the customer, the developer will starts the work on developing the software. So this is the burn-in phase. So this is basically the product type, okay, because any product have a wear out phase. There is no option that is the hardware does not wear out. Basically when we develop any hardware product, then it recognize good, and this recognition is known as the useful life phase. It means we have to use that particular product in this particular phase. So this is known as the useful life phase. So basically any hardware product, when we have to develop any hardware product, so basically that product have the three phases, that is the burn-in phase, useful life phase and the wear out phase. So after a decade or after some years, every hardware product goes into the wear out phase. So this is the basic working of the hardware product, and this curve divide into the two parts, that is the failure intensity and the time. So when the time increasing, so the productivity or the wear out condition of the hardware product is goes down. So this is every product and every hardware product comes in the wear out phase from the useful life phase. So this is the basic diagram of the hardware curve. This curve is known as the bathtub curve. This is very important topic of the software engineering, that software does not wear out. So let's see the software curve. Basically, when the failure intensity increases according to the time, then software is retired due to the environmental changes, due to the some changes, any changes. Software may be retired, but it can't goes to the wear out phase. Means we always adapt the new changes, we always accept the new expectations, we always change the requirements according to the user demands, but somehow the code when we have to develop at the time of the development time of the software, so this code we have to use after after a long time ago or after some changes. So this code we have to reuse after some time, but it always have the useful life phase. This never goes to the wear out phase. So this is the basic software characteristics, and this is very important. Now the basic failure curve of the software. Software doesn't go to the wear out phase. How and why? Basically, when we change any software or the requirement of the customer has changed according to the time, so we just inbuilt these changes of the defined software components. So first we have to change that particular software. So there are some side effects over there, but maybe we have to go up for these changes, or we have to go down with these respective changes. But after the resultant, that we find out that after some changes that we have to goes down, but sometimes we goes up. Then again, when we again change the software, then we have to goes down. Then again we goes up, and at this condition we find out the actual product that we want. So basically, when we have to change the requirements, change the development procedure, change the expectations, so after some time we have to achieve that particular software that we want. So basically, the software does not goes to the wear out phase, but the hardware goes to the wear out phase. So this is the basic characteristic of the software. Now, the second characteristic is that software is not manufactured. So this is what this is. When we develop any software, then the production of the software is varied from time to time. It means if we define a procedure or we define the code of the software, then we always take the multiple copies of that particular single event. But at the time of the hardware, when we produce any hardware product, so we don't take the copy of that particular product. Suppose we required 100 copies of the benches and we develop a single bench, but we don't take the copies of these benches because these are useless. But in the software, when we define a code for the library management system and we want this code is have the 100 copies then or the 1000 copies, then we have to copy that particular code with the 1000 number of fields. So we easily do that in the software field, but this is not done with the hardware. So basically, software is not manufactured, otherwise the hardware is manufactured, but software is developed. Basically, software is developed because there is no retirement phase, there is no wear out phase. So these are the development phase according to the time, according to the procedure. So this is not manufactured. The third characteristic is that software is logical rather than physical. This is very true statement. How we have to define that particular statement? Hardware is the physical entity because we have to realize the hardware components like the touch of the table. We realize that this is the hardware component or this is presenting here. But In the software part, we have to develop any code, then this code have the logical errors, the changes are possible in the software, but in the hardware we don't change if we have to develop any hardware product. So this is the third characteristic of the software. Now the fourth characteristic is reusability of component. We always reuse the component or the module code that we have to develop the new software, but in the hardware phase we don't have the reuse component with the reuse component used for develop the new product. So this is the also the reusability of component with the software also. Now software is flexible because we have to change the software according to the time, according to the requirement or the changes of the customer requirements, but in the hardware we don't do that. Now the last point is that most software is custom build up and that is being assembled from existing components, because we don't require the number of components that we have to develop any software, but we require the number of components when we have to develop the hardware part. So these are the characteristics of the softwares. Now the type of the softwares. Basically we have the number of type of the softwares. First is the real-time software. Real-time software is what? Real-time means we have to define anything with the real time. That means we have to take the responses at the current time. We take the guarantee of that particular component with the defined time. So basically, we have to do anything with the defined time or the defined interval. Basically, there are the two types. First is the hard real time and second is the soft real time. What it means, the hard real time? Hard real time means the deadline is fixed. We have to never change the deadlines. So hard real time means we have to define the time, and according to the time we have to display the result. For example, if we launch any space or launch any missile, then the time is fixed. So at that particular time we have to launching the missile, or the flight control system. So that is the that is very defined time. And the soft real time is that suppose we have to transition with the bank, or suppose we have to take the results from the bank side. So sometimes the message, suppose we have to submit the amount in the bank and the time is 24 hours. So this is the variable time. This is comes within hour, this is come after the 2 hours, this is come within 24 hours. So basically this is the interval time. So this is the soft real time. Now the system software. System software is what? System software means we have to manage all the resources that we have to use with the system, and we have to support the system to execute any application. So this is the system software. Basically operating system is also a system software that we have to use to define the system with the defined machine dependent tools. So these are the system software. Now the networking and the web applications is that suppose we have to transfer the data from the one place to the another place. So we require the networking from like as LAN, MAN, WAN. So we store the results with the networking part. We transfer the product from one place to the another place by using the networking in the software field. So these are the basic tools that we have to use, or we have to support the networking softwares. Web-based application, like as the application softwares that we have to develop, and these application softwares is defined by the user part. So these are like as HTML, PHP and the XML. So these are the web application softwares. Now the embedded softwares. Embedded software means we have to define the hardware component, and we have to inbuild or embedded the hardware component with the defined software, or we have to introduce the software with the hardware part. So this is the embedded. Suppose we have to embed the control systems in the machines, like as a washing machine, AC controllers, microwaves, refrigerators. So these are the basically control systems that we always embed with respect to the softwares. Now the reservation softwares are used. This is the basic that we have to use to store and retrieve the system, either the user information or the data of the user, or the reservations with respect to the money point of view. Suppose the user give the transition from the one place to the another place, then we have to easily recalling the system that we have to fetch the data or we have to store the information in a storage system. So this is the reservation softwares. And what is the business software? Business softwares are used basically in the type of the account system, type of acceptance system, type of banking system, hospital system. Any business, we have to use a simple software that is support the business applications, that is known as the business software. Now the entertainment software, entertainment softwares means we use any tool that is used for the by the children for the entertainment, like as gaming, or the educational system that we use online system for the transcriptions of the text form. So these are the entertainment softwares. Now the artificial intelligence software, these are the expert systems that we have to use and that have the power for making the decisions for a defined concept, or any system that we have to use for the learning procedure. So these are the artificial intelligence systems. Now the scientific softwares are, these are the basic softwares that we use for creating the scientific data, or we have defined the results like the MATLAB, AutoCAD. These are the basic examples of the scientific softwares that used for defining the performance of the system for a specific task. So these are the scientific softwares. Now the utility softwares. Utility softwares are what? Utility softwares means we have to utilize that particular software in a maximized way, in a qualitative way, in a quantitative way, or a defined time intervals, like as the antivirus. Antivirus is always run in the system according to the time to time procedure. Now the next is the document management software. Suppose we have a database, or we have a document that we have to use for tracking the system, for managing the attendance, for take the records, for define the paperwork in for reduce the paperwork by defining the these type of application in the system. So these are the document management software that we have to that we have basically used for the reducing the paperwork. So these are the document management softwares. So this is for the today's lecture. Thank you so much.